Thank you. So hi, as Derek mentioned, my name is Jeremiah Guthrie. I've been with Microsoft a couple of years. I'm an architect here in the West Midwest region, focused primarily on app innovation stuff. So that we kind of it's a big umbrella of stuff that you use to build in Azure. And so, as part of that, one of my more interest areas, I guess hobbies you could say, is kind of this concept of observability. And so I'm delighted to have the opportunity to kind of share with you a little bit of Microsoft's perspective with also kind of a slice of my own kind of thrown in here. So if you have any questions, please throw them in chat. We'll do the best that we can. Derek's a great MC, so I'm sure he'll chime in and I can answer any questions that you might have as we go.
Actually, Jeremiah, if I may, please post your questions to the Q&A panel. The way this meeting is organized, that's where we can respond to you. Thank you.
Thanks, Tom. All right, so it's going to be a pretty tight presentation. Got an hour, and this is a pretty big topic. So first, we're going to set on some fundamentals. So fundamentals of observability, and then I'm going to go into a little bit of what defines kind of modern monitoring and modern and observability, and how those are separate but very interrelated practices. And then we'll close this out by actually looking at some demos of the tooling that exists in Azure, because I find that if you are like me, sometimes it's a little hard to keep up. Azure Monitor is a big umbrella, and where does that kind of begin, and where does App Insights begin, and Container Insights? And so we'll talk a little bit about the strategy there, and then make that a little bit more real by going through a demo. So fundamentals of observability. We'll get in and out of this fairly quickly. There are three main pillars that define modern observability and monitoring. Those being metrics and logs, which I think those of us who've been doing IT for any length of time will know have been around forever. So metrics, obviously things that stream off of applications or servers, and mostly is at the infrastructure level. So, response time, yes, can be argued as sort of network plus your application consumption on the other side, but CPU utilization, memory utilization, things like that fall under this bucket. Logs have become ever more important. Gone are the days where you could kind of get by with just Event Viewer on your local server. Applications at this point stream off tremendous amounts of logs, especially in cloud-based applications where things are very much composites, which then brings us to the last pillar, which is traces. So traces are things that I would say have become much more important. They were always important in distributed applications before, but a little bit more of a secondary concern. I think since you've seen a move to cloud and cloud native platforms like Kubernetes, traces have become much more of a first-class citizen, so much so that there are multiple different open source CNCF projects that deal with tracing, to the point where OpenTelemetry has kind of come along and said, okay, let's try to provide some uniformity here from a standardization standpoint. And we'll talk a little bit more about OpenTelemetry and where it's going in the overall arc of kind of Azure Monitor itself. So the key idea to take away from here is that you get insights out of observability, you get your benefits of monitoring based off of these three pillars, and they kind of are the foundational elements that form everything that we're going to talk about today. So monitoring and observability, they're related, but they're based on the same foundations, and they serve slightly different use cases. So in monitoring, and I have a picture of kind of it's a Dolly generated report card image. So for those of you that kind of like have kids in school, right? Like this is sort of how you are monitoring your children's progress, right? It's how I was monitored when I was growing up. And so monitoring is sort of similar. You take metrics, you take logs, you take traces, and you set alarms on those. There's thresholds, whether those be defined by business SLAs or whether they're just defined by operational SLAs for a particular piece of infrastructure. There's something that you care about, and it exists within a threshold. And if you cross out of that threshold, you probably want a bell to go off because you need to take some type of a corrective action. So it's a reactive process. Hopefully 99.999% of the time, everything is great. And these are just happily humming along, displaying that you are within the boundaries of what you deem acceptable. But when it exceeds that, monitoring is sort of like driving that alert and then driving you to action. And we'll talk about the concepts of it now, right? So the first concept is this idea of health checks and synthetic monitoring. So health checks can be as simple as setting an alert on a server, right? So where I used to work in enterprise, we had a pretty standard threshold. If CPU was above 70% for, 10 minutes, then ultimately what you needed to do was alert on that, because someone had decided that 70% utilization, you started having to worry about what was actually happening. The other side of that is that's just sort of a kind of a crude metric. It says how utilized something is. It doesn't actually tell you much about system health, just it's a kind of a precursor warning. Someone had once upon a time learned that if it goes over 75%, you start getting resource contention for CPU and maybe you need to take action. This idea of synthetic monitoring, though, is kind of a more modernized take on that, which is for an application, you as application owners, as architects, as developers, you know that there's a particular flow in that application that when a user experiences a negative event in that, that's how you're going to know something's wrong. So it's smarter than just a single metric streaming off a server. It's kind of a composite of a few things. And so this idea of simulated user behavior through synthetic monitoring, maybe it's a login process that you're constantly logging in and logging out. Maybe it's the process of adding something to a cart. Maybe it's streaming telemetry to an endpoint. You can set those synthetic monitors, and then you can just sort of monitor the results the same way you can with that simple server metric. There's a threshold, there's an exception to that threshold, and then you can kick into these ideas that you get, or these capabilities you get from Azure Monitor to do things like trigger an alarm, begin your remediation process. Alerting and notification is kind of the next step of that. So I've touched on it a few times tangentially, but one of the really critical things in monitoring is this idea of alerting and then what you do with that alert. And so rather than the olden days where you would have sort of folks that would sit watching a operations center dashboard, instead you can actually have something else watch that dashboard for you and alert you or take corrective action. So again, I'm kind of older in IT these days, so I still do remember when pagers were actually pagers. Nowadays, it's sort of, you've got multiple different channels, and we'll explore some of this when we look at the alerting capabilities of Azure Monitor, but you can get everything from kind of the classic SMS or email that says, hey, Jeremiah, wake up, there's a problem, go fix it, to actually more compelling use cases in my mind, which is, if you kind of, when we get to this kind of next step of this, where we talk about triage activity, if you take your root cause analysis and you find that it is something that you can automate, and this is actually one of the beauties of modern cloud-based platforms, is the idea that you can have a synthetic monitor, have a traditional alert that you know that if this is happening and it works in this time window, and that triggers an alert, these were the recovery steps we took before. And if you can automate, you can actually have platforms like Azure Logic Apps take those actions on your behalf to restore service without actually having to wake someone up, and to provide kind of a faster turnaround to get back to full capability or capacity. Which brings us neatly to incident management. So this is kind of what happens when the alarm triggers, right? How does the fire department respond? And so it's to ensure the fastest possible recovery time from a degraded state. And again, when we get into kind of the demo portion of this, we'll look a little bit around what Azure Monitor sort of enables for this. But a lot of you in your corporations will probably have incident management tooling already. And so the call out here is, the Azure Monitor platform, Azure as a whole, has a robust connective ecosystem. Some of these are pre-built to some of the largest incident management platforms on the market, things like PagerDuty or ServiceNow. Those are convenience integrations, but there's nothing stopping you from being able to integrate with any incident management system that you use. It can be tied still to the same type of alarms. You can still have the same actions taken. Flipping over to observability. So if the first picture was a kind of a kid looking at a report card, kind of that after the fact something's happened, we're grading it. Observability is more like, how do I see inside, or how do I, from the outputs, how do I infer the internal state of something? So this is a little bit more purpose-built. It still uses the same signals that we talked about, so traces and logs and metrics, But it's for bringing all of that together along with some consumption tooling to be able to do deep dive diagnostics into complex issues, or as in a couple of the example cases I'll give at the tail end here, which it's making design decisions, either as a product or as an architecture, to pursue characteristics of your system that you want that didn't necessarily manifest until it saw load in production. And so it allows for this concept of exploration. So the first concept of observability is this idea of correlation and then contextual analysis. So all of you, I'm sure, have a pretty rock solid operational process. That's most likely evolved over time as tooling's gotten better and as your environments have become more complex. One of the things I'm sure you're all solving for or have solved for is this idea of you're getting all of these different signals from these different applications. How do you bring them together in a collective place? And then how do you bound them in a way that actually matches the domain that you're trying to go after, right? So I have worked with customers who have kind of gone really deep into some of the signals and the traces to the point where they're doing network capture. And one of the tricks with when they do that is by the time you're on the wire, you are so far removed from the upper layer protocol. How do you correlate those individual packets that ultimately, resolve themselves to TCP and then let's say like a layer 7 protocol like an HTTPS? And so that concept of observability where you're able to actually create that correlation, and then there's tooling that you can start out at the high level, observe the application, have a theory, work to the next level, and drill down into the details to ultimately find patterns that you're looking for or explore new ideas and then be able to test against it. It's kind of the knock on or kind of the end result of this modern practice of observability, the ability to be able to tie things together and then to be able to contextualize it within a scope or a business domain. The next bit of observability is anomaly detection and predictive analysis. So a lot of you will probably know this as kind of that emerging field of like AI operations, where the data and the amount of it and the velocity of it is getting so high that unless you have dedicated data science teams that are looking at operational use cases, there's probably a lot of things that could be caught being left on the table. And so this idea of being able to do anomaly detection so that maybe you don't have to code a model that knows like fine-grained details of your business domain. Instead, really, maybe it's just a little simpler that says, this is the average response time in this particular time window, and we notice that there's been an uptick. So what happens then? Maybe send an alert, right? It's not necessarily an indicator of upcoming failure, but it could be an advanced warning that maybe that last code change introduced an unintended consequence. Maybe there's now a memory leak where one didn't exist, or maybe there's a code path that is a little bit slow compared to what came before. And then the next bit is predictive analysis. This has a lot of bearing in sort of, I would say if you're still running sort of IaaS infrastructure, there's a lot that can be gained out of something like this, where you can look at, I kind of harkened back to that early experience I had of at 70% CPU utilization, we need to start looking at the server and need to think about ordering for next year because, we're on an annual sales or process of buying for capacity. A predictive analysis allowed you to kind of forecast your needs. Now, the benefit of the cloud is you're not on an ordering cycle. You can just get more. But by the same token, you can use things like predictive analysis to understand what your growing capacity needs might be, and then to optimize maybe your cost model through things like reserved instances to be able to serve that capacity, but by the same token, reduce or control your spend. And then finally, observability is about continuous improvement and feedback loops. So I mentioned that there's going to be a little bit of my own opinion in this. This is kind of where I'm getting at. And I'll give you some examples from my career that I've noticed and kind of some things that I've seen that were what I consider to be pretty good wins out of this concept. So the proactive nature of observability lends itself really well to this idea of kind of the scientific method, right? That continuous feedback loop where you observe your application. Maybe you're wondering why your conversion pipeline of customers has a hang up, right? Why do you see a drop off on, some percentage of customers? And you ask yourself the question, you come up with a theory. You can actually test it because, you can deploy it into the cloud. You can have a controlled test where a particular user group is now on the new path versus the old. You're still kind of reaching the same objective, but maybe the user interface has changed slightly. You can then run analysis because of that correlation, again, in those signals that you got on whether or not your experiment was true, right? Did you achieve the result you were expecting? If not, can you keep iterating? Or if you did, great. Like that's an improvement now that can go into the backlog for your team and you can move forward. So I mentioned I was going to give some examples of this. So about 5 or 6 years ago, I was working for a bank that did a integration or kind of a purchase of another bank. And in those cycles in that business, he worked for months and months and months to migrate all of the data over. And typically you close both banks for the weekend. And typically you pick a holiday weekend, so you give yourself a little extra time. And then everyone holds their breath at about 6 a.m. on a Tuesday when the banks come back up. And now the customers of the acquired bank are the customers of the new bank. What's the first thing that you would do? I know it's the first thing I would do if I was being acquired as a customer by a bank. I'm going to log into online banking and check my balance to make sure that money didn't get kind of lost in the exchange. And so we had a very real scenario of this where the onboarding of these customers from the acquired bank onto the new one, it coincided with probably week 4 or 5 of a refresh of the online banking application. And now a couple of things had been critical to the design process of that new online banking portal. One was really deep telemetry being baked in on the user interface side. So, things like where do users spend their time from a mouse hover? How long does it take to find a button? We were streaming all of that back. And the other bit was it was kind of the first taste that I got of container-based deployments. And so the front end of this was running on Kubernetes at the time on-prem. And what happened was by about 10 a.m. Eastern time, it was pretty clear from a signal that we were getting from the actual call centers that there was an increased volume, way more than what you project. You're always going to have increased volume in a call center during a conversion event like that. But like the numbers were out of control. We're talking like 45-minute wait times for customers. They were swamped. And so we started getting information back from the call center on, there was a common thread in this. What was happening is these converted users, their accounts are being locked out. Well, this was the first conversion I'd been a part of where we were trying very hard to do a much more secure migration. So what we were doing was people would be mailed like a one-time code, and their user ID had been moved over from the old bank, but obviously the passwords weren't. You're not moving passwords. And so we had a form where on the left-hand side of the form, you had username, password, login. And on the right side, there was some text blurb of like welcoming these new customers and explaining how the process was going to work. And what we kind of hypothesized was, given the number of lockouts, people weren't reading the instructions. They were coming in to the portal. They were using their old online banking credentials, and they were just hammering it. Maybe they mistyped the password. Maybe, the service was behaving oddly, is what they thought, right? But anyways, they were hitting the password lockout. And so then the user ID was just fully locked out. And when that happens, the only way to actually fix it is to go and kind of call somebody, hence the long call queues. And so there was a pretty gifted user experience designer who took a look at this and said, well, I have an idea. Our customer base, they tend to follow with their eyes left to right, right? It's a Latin-based language. And so they proposed a change and said, what if we just flip the screen? So we'll put the username and password box on the right, and we'll make the text of the instructions for these new customers more front and center. So they agreed. They actually made the change, and this was kind of the cool part is they deployed it middle of the day, rolled it out lowly. So they were doing traffic splitting. So something like 10% of the user volume was now on the new path, and the other 90 was still on the old. And what they saw was as they bled traffic over, right? Because they're going to kind of that 10% meant, okay, the flow is working, right? We know the code works. So you can start to bleed traffic over at a higher percentage. And what they saw was within a couple of hours, those call queue lines came way down, because what ended up happening is the theory actually proved correct. The screen had been laid out to promote sort of the form aspect rather than the instructions, and people were just going straight to the form and hammering it. And so it was this really neat sort of experience where you sort of see that you've got that telemetry that we were able to get, not just from disparate sources like the care center, but also from the user interface, because you could see where people's mouses were and like how fast they were hitting the text box from page load. And you saw the telemetry when the form changed, how it shifted to favor the theory that was devised. And so that to me was a pretty compelling story of observability. The second one is actually more of an architectural change, less of a user interface change. So I had responsibility at one point for some developers who were working on an open banking project, and open banking involves a lot of the interactions with financial aggregators. They tend to work in batch windows, so they're quiet for a long time, and then they're not. They're really noisy. So lots of very high traffic. We were operating in a microservices environment, so high traffic at the gateway tended to ripple out to high traffic in a lot of other services downstream. And so we had a theory that there were certain call types where caching would really benefit insulating those downstream systems from the noise during batches. But we really didn't have an idea of how our caching strategy would behave off the whiteboard and in production. And so what we ended up doing was we would instrument the code that was going to make cache calls to basically capture and record and emit a metric for cache hits versus misses. And so we were able to create several caches for different object types. And we were able to sort of fine tune our cache settings, so times to live, cache eviction rates, and the amount of memory that we needed in these caches in an intelligent way. It wasn't sort of just guessing and turning knobs. We actually had the data to back it up and could make those decisions proactively with insight. And so to me, that was, again, another example of sort of observability in action. One to solve a very user interface kind of UX problem, and the other to solve a more software architecture problem. So this is just a quick summary of the two. I won't read it to you. You all can kind of get there, right? But like, I think the biggest takeaway is observability is more of a proactive exercise. Monitoring is more reactive. Something's happened and we need to fix it. And observability is more like, well, yes, if the kind of triage process is so complicated, it's great to have observability tools to be able to peel the layers of the onion back. But observability's bigger power, in my opinion, is when used outside of an incident to constantly improve your system, whether that be from a user experience and kind of modifying the application to better drive the user behavior you're looking for, or to improve the characteristics of the architecture that you define during design. So last slide, I promise, on kind of this more theory stuff, but they're not separate practices. They're very complementary. So that measuring and detection and alerting that you get with monitoring flows very nicely into the response of observability, right? If you have to cross over from the simple triage to the more complicated, you're gonna be really glad that there's observability tooling there to do it. And then learn. And again, that's pretty much just classic modern DevOps. Always learn from your incidents. Learn can be taken and plucked out of this diagram and used by itself too, because it is, again, that kind of proactive process. So we'll do a couple more slides and then we'll swap over to the demo, but I want to talk a little bit about the holistic observability and monitoring stack that exists in Azure. And I'm not sure until I kind of stumbled upon these diagrams. It's as I mentioned at the head of this conversation, it's always challenging to conceptualize Azure Monitor because it's a giant umbrella. It's scoped to a tenant, which always makes it a little bit, for me anyway, a little bit more challenging to kind of comprehend because there's only one of them. It's just like Active Directory. Like I mean, you can have multiple directories, but there's sort of one that covers everybody. And so we're going to walk through piece by piece from left to right what these stages of the architecture of Azure Monitor is. But I think it's important to see it in its whole. So there's the idea of data sources, which we'll get to in more detail in the next slide. But Azure Monitor then takes responsibility for having this data collection and transformation and routing, landing you in different data sinks, then that data platform. And then finally, it has a lot of built-in tooling that integrates with a ton of our various product types for consumption of those. So that idea back in the observability slide, you've got that kind of correlation, but then you have the consumption. There's a lot of tooling to do consumption. Some are more deep and kind of opinionated insights. Others are freeform that let you sort of explore depending upon how deep your data practice is. And then finally, there are ways to be able to exfiltrate the data to any platform of your choice. So let's talk real quick about the data sources. So there are, I'll say, different levels of this. There's the stuff that you get quote unquote for free, as I like to say it. So there is a agreement in Azure engineering. Your service doesn't get into the Azure portal as a first-party Microsoft service without logs and metrics being defined and being configurable. So these are in any of the resource blades that you might look at in Azure, app services, function apps, even VMs. There's this idea of diagnostics settings, and you can go in there and define that you want to capture logs that are defined by the product team, and those can be directed to that data collection. They are the only work on your part is to configure them. Just say yes or no, and the log type you want to capture and the destination it goes to. There's really no more lift on your end. The next bit is that collection by agents. So let's say that you enable VM insights or container insights. These are agents that get installed either on a VM or in Kubernetes case as a kind of a daemon set on the nodes, and I won't say they're agentless, but they're codeless. And so what they do is they act on the side, collecting metrics, collecting some of that logging, like maybe the more detailed logging, and doing the same deal. So these are a little bit more involved. Like with an Azure VM, it's a policy-based thing that you could technically deploy it to the fleet. Container insights, it's on a Kubernetes cluster by Kubernetes cluster basis. But you have the ability to be able to deploy that. It's an agent that Microsoft maintains. They'll handle the update of it. And then from there, it ships that information over again to the data collection platform. And then finally, at the top level is application insights. So there's a couple of ways of doing this, depending upon the depth that you want and the language that you're using. So there's a no-code deployment, and then there's an SDK-driven one. Full disclosure, the SDK one will get you deeper insights. But from a convenience standpoint, if you are running in one of our PaaS platforms like app services, and you just turn on App Insights, it will begin collecting fairly good metrics, tracing you get kind of for free, just as part of the service. And same deal, it will emit all of that stuff to then not just a data collection point, but also bounds it to a domain for your application, and then has a number of insights and visualizations that come just with the product. For anything else, any custom sources, let's say that you're running a hybrid setup where you're using, Datadog or something on-prem to collect a lot of these, and you want to create a single pane of glass across your on-prem fleet and sort of your stuff in the cloud. There is the possibility of using not only agents, if those are VM based, but let's say that you've got a custom emission from a virtual appliance on your on-prem network. As long as that can emit and you can talk to a REST API, you can define a custom source and still have it land in Azure Monitor, which then brings us kind of nicely to this idea of data collection. So I won't go super deep into this other than to say that everything that we saw on the left as far as sources, they come in through one of these either predefined gateways or through something that you yourselves can kind of configure. So these idea of like data collection and routing, this is actually a kind of can be aligned with an API. So for particular data collection types that you define, you can give conditioning and routing rules, so transformation rules. You can, this is also a really great capture point of modifying kind of how much your spend with this is going to be, because you can do pre-filtering at this layer. So instead of having all of the data of your stream, like 100% land in the data platform, you can basically make the ingestion point fairly dumb, right? So like the emitting side, the data source doesn't really have to pre-filter. It can just at the API, and the API can filter out the stuff you actually care about and only let that through, which means that that's the only data being collected and its size is the one that's growing and kind of driving a lot of the cost. And then finally, the data platform. So these should look really familiar, right? But that metrics, logs, and traces, they all wind up here. And the shapes here are a little bit different. They do have some meaning, right? So metrics, sort of the default Azure Monitor metrics collection, as it has sort of always been. But as Prometheus has gained in the marketplace, we are starting to do things like manage Prometheus. We're starting to be able to consume Prometheus style metrics as well. Logs and traces, these end up in log analytics workspaces, which for any of those of you who have dealt with that, what it ultimately ends up being is a series of append-only logs that sits and is kind of created into a virtual data warehouse. And you use things like the Kusto language query, or the Kusto query language, to be able to query against those. So there's table definitions, and those are just virtualized tables across huge quantities of these flat file logs. And then finally boils over to the consumption end. So with that, I'll swap over to a screen, the other screen with the demo. But before I do that, Derek, Tom, is there anything Q&A wise we want to hit on before we move over there?
Nothing in the QA window so far.
Okay. This either means this is really boring or you all are really good at this already. So what I'm going to do is spend a couple of minutes walking through application, or kind of a structured demo of the various aspects of what we've been talking about. And so all of this that we're about to look at, it does fall under that Azure Monitor umbrella. And I'll try to do the best that I can as we walk through these various pieces to call out which aspects of that stack that we're seeing, as well as kind of talk through the application that exists underneath this whole thing. So we should start here. This is not a prepackaged thing, but what these are is one of the capabilities of Azure Monitor All Up is because you've got that data sync of all of your metrics and all of your logs all in one place, you can create scoped dashboards of your choosing. And you can have these appear as your kind of entry page when you log into Azure. You can scope these for individual teams. So different teams, let's say that I've got an application team and maybe a team that's site reliability engineers, right? Maybe they want different views of their environment. It's still based on the same metrics, but the views that they care about are maybe different. This is a really great way of sort of creating that dashboard based on that monitoring construct. And so with this, you can see that it's broken down into 4 groupings. So usage data, reliability data, responsive, and then browser insights. And so what we can kind of see here is this is sort of where, you might come here a couple of times a day just to sort of check in on things. The reality is if you end up getting an alert, this is probably where you've started. You've come here to see where exactly the system is all up before you begin kind of the rest of the incident management process. Diving down into the next bit of this, if we move into what would be the next logical response if you started on your dashboard and you saw you had a problem. So this is application insights. And so what I'm going to talk a little bit about is scoping, because there's some best practices with this stuff that we can give high level guidance, and we would love to spend time kind of talking about your specific cases. But largely, what I don't want you to walk out of here with is this idea that because we make it really easy in an app insights instance to create a new log or application insights from an app service, right? That every app service you have should have a different app insights instance. What you will have if you do that is you'll have really deep telemetry and really deep visibility into that one thing, and maybe one step away with its dependencies. But what the example here is you have actually multiple applications that are collecting into this one application insights instance because they work together for a single business outcome. And so the team that potentially develops all of this might be the exact same group of developers, or it's the exact same site reliability engineers. And so those applications feeding into a single source gives this fuller picture, right? So it's this balance when you create app insights instances between how much cohesion you want of the environment versus how much noise you ultimately end up with. Because you could go crazy and have, maybe this application over here is a dependency, but it's a pretty rare one. That might be less important to see within the holistic view here than it is to kind of dial back the noise and have just sort of like the pieces that contribute to a business outcome in this single view. So in this case, it's a hotel application. So runs the IT operations for a hotel. So managing customers, managing hotel rooms, bookings, all of that kind of fun stuff. And so those pieces that kind of work that path are all in this single solution. And if we kind of swivel this around a little bit to a different layout, it starts to make a little bit more sense seeing how the application itself flows. But you get this nice map of the overall application estate. So these are the kind of these are the instrumented pieces. And so we've got a piece in Kubernetes. We have a web page, so static web assets over here. I think it's a node. And then you have like a .NET app service. And you can see downstream what the dependencies for those are. You can see the failure rates, the number of alerts that have come out of these, and then useful information like the number of calls and the duration of those calls on average. And this holistic view is really nice, but let's say that you ended up with a problem where you got an alert from your monitoring system. Your synthetic test for users is showing a heightened failure rate. And so you know that involves the web component, and you know that it involves maybe that kind of piece that's in Kubernetes. And so, yeah, you can sort of in a map this size, you can pretty easily dial down the noise by just zooming in. But you have the ability here to be able to refine this graph based on different filter criteria. And so in this case, if I say, okay, I only want to see node sources and targets that touch the AKS application. So this AKS notifier. And down here, you just kind of see what it's going to do, sort of trim this down by. And now all of a sudden, we've got kind of this much more tightened up view. And we can see the number of calls we're making and kind of see the failure rates. So this kind of begins that idea or that triage process. We can then drill into the details of this particular node. And we can see, again, this is that idea of correlation on a business domain. So under the hood here, Application Insights has collected logs, metrics, and traces from all of these instrumented applications and is trying to be as helpful as it can be, right? So these are typical investigation areas that we ourselves use. And so we've raised these up in this interface for customers. So you can see the top failing requests by name. You can see the slowest requests. You can see the common properties for those failures. And so if we take this memory leak, for instance, you can begin to go into the process of seeing more information about it. And so obviously you can tell that this is a scripted failure because it's very regular on wall clock time. But if we were to say, okay, well, let's look at some of the samples that exist for this 500 error. We can kind of drill into the sample a little bit, and we'll take the suggested one. And what'll happen is this was a particular deep instrumentation for application insights. Most likely the SDK was integrated with this particular Java application, but you can get the actual full call stack of what happened here. And so with that type of information, you have the ability to be able to kind of invoke that feedback loop that we talked about. And so you can create a work item. So this work item can go into Azure itself, or it can go into integrated source control management and project management tools like Azure DevOps. And what you'll get is you'll get a task or a bug that will basically have all of this information slipstreamed into that object and tossed over into your backlog. And so maybe you have an ability to be able to fix this quickly, or this Java heap space, maybe you temporarily just do a complete restart of those particular containers while the development team works on a patch fix that fixes the memory leak all up. So that's kind of the idea behind the beginnings of triage and how you use some of this information. One of the things I also wanted to kind of demonstrate was there is a wealth of investment that's going on in this type of tooling because we ourselves use a lot of this tooling. And so as we're learning more operationally of running the Azure global fleet, there are certain proactive notifications, smart analyzers, anomaly detections that we have found useful. And we can generalize those into patterns. And so one of the nice things that has come to application insights and continues to be an area of new feature rollouts is this idea of smart detection. And so if I say smart detection time range for the last 30 days and I have it go run this, what you'll end up seeing is there are a bunch of different anomaly types that it can detect. And you see a small subset of them are kind of in general availability, and others are in preview because we're still kind of working out whether or not they're useful. And whether or not they detect what we think they detect for customers. But when you go back to this, you can actually see that these aren't necessarily things that would have triggered an alert, but they are things that potentially could be early warning indicators, right? So if you've got an abnormal rise in exception volumes, so we can take kind of a deeper look at this and say, because this is a demo environment and that exception is rather regular, the normal exception volume is really high, right? But this not a normal detection volume is like exceptionally high. And so you can start to get into some more details, and this begins to kind of start that kind of observability wheel that we talked about for, what did you observe? What's the hypothesis, right? So if I go to this and say, well, okay, I've got this spike in new exception types. What happened in and around when that started? Was there an operating system update? Did we push a new version? What else might have changed in the environment? And so it begins to allow you to ask those questions, and then you can continue to use some of the observability tooling to dig into the environmental factors around that span of time, because now you at least know it's like, okay, well, this started spiking. Even if it went away, it'd be really nice to understand sort of what caused the spike to begin with. And so you can begin the process of working backwards and root causing it, and potentially finding process changes that would prevent this type of thing from happening in the future. Mitigation strategies, if it's something that was inevitable. Maybe it was a patch that you took. How in the world do you kind of protect yourself upstream from, say, an operating system patch? I mean, there have been sort of some interesting ones. So I deal with AKS a lot, and about a year ago, I guess, we had an upstream patch that came from Canonical that had a bug in it. And as it rolled out across the fleet, it started taking workloads offline. Now, this type of advanced notice might not have caught something like that, but it is certainly an example of something that we looked at internally and started coming up with mitigation strategies to make sure that didn't happen again. And so the idea was born to kind of we take the patches, bring them into our own artifact management. We run the patches kind of against some small, like, well, not small, but some kind of internal clusters first, and then sort of vet those before they move out to the broader fleet. It introduced a little bit of friction into the overall system. So there's some patches that are delayed, but the overall outcome is that there's higher reliability of those patches when they kind of meet customer workloads. So this is something that if you're using application insights but not looking at these, I'd suggest taking a look. It's included with the service itself. And as I mentioned, it is an area of investment, as you can kind of see with the doubling of the number of these detectors that have been put into this. So it's incredibly useful. Kind of moving down the stack here a little bit. So whenever you have, let's say you want to see as part of your incident management, maybe you've seen where the failures are, but you don't necessarily, you want to see kind of a holistic view of all the metrics across the system, and what exactly sort of going on at that particular point in time. Live metrics is actually a nice view because it consolidates everything. And so you're sampling your telemetry, you can kind of see in real time where there's problems, right? So this is a common one to see in this dependency, this 409. There's times where you're just hammering this storage API so hard that it 409s on you. And then, obviously it retries later and then comes back, but it's a nice way of being able to see everything and then filter down from there. Again, a lot of these types of incident management is about starting at that highest level of observability and then drilling further down. And that actually kind of brings me to, I guess it won't be this. Whenever you've moved past that kind of upper level of visualization and you need to do a deeper root cause analysis, typically you'll end up here in log analytics, because depending upon what you've captured, there's really strong capabilities to do correlation here. And so if we take a look at this, and look at a typical diagnostic workflow. So in this case, these are queries that someone has created that was deemed useful in the past, right? And so if we look at this, there was a problem with a particular server. That server runs your application, so we know it runs IIS. And so you can actually take a look and see a chart based upon sort of the app KPI, so how fast it's responding, versus what sort of the server KPI is. So up here you can sort of see the query as it was created, right? There was this idea of the time taken for, so time taken from a response time. We create this SLA index. The baseline of the SLA is 99%, and so we calculate sort of the total time that the time met was succeeded versus when it was met, and then we marry that up to application requests. And so you end up with a with a view like this that shows that, well, every time the server spiked and started missing, you could kind of see that there's a correlation between these two things. And so you begin kind of the next phase of investigation, which you take a look at what the CPU for that is. So normally the first place people look, CPU and memory. And you sort of see, okay, well, there's these spikes where the CPU goes to 100%. And so you start to take a look and determine whether or not, well, was this some other process running rogue on the system, or is my application and kind of its ability to serve these requests something that's causing this problem? And maybe from there, my triage might go a different direction. But you can then join up kind of these two graphs and see there's almost it's almost a perfect relationship. Every single time that the CPU spikes, it correlates with a spike in app requests. And so that gives you now correlation between these two things. So it doesn't necessarily mean causation as we know, but it's at least some place to start. And so from this, you can return to something like an app insight using these timeframes that you've got and you can start to do a deeper analysis into what were those requests. Is there something about the payload of them that might have caused this? But it basically gives you that ability. Again, you're collecting all of these things together, and you've got this tooling that sits on top of it where you can just kind of keep peeling off layers until you ultimately find out what your root cause was, and can come back to a good state. With that, I guess I'll touch real quick on kind of the last bit of this. So we've talked a lot about first-party tooling. We're pretty confident in kind of its capabilities and sort of the story that we have to tell around it. But we also recognize that there is great work being done in the open source community, particularly around Prometheus as far as metrics collection, and tools like Grafana for visualization. And so this is an example of kind of a managed Grafana instance. And so what has been done is Grafana has plugins to be able to talk to different data sources of metrics and traces. And so one of the things that's been kind of built out is this ability to be able to talk to that source of Azure Monitor data and raise it up into these pre-built workflow or dashboards. And so in this case, this is a managed Grafana dashboard with for Kubernetes. And so you can kind of see here, this is just a sliver of that overall environment we looked at, right? That was that Java component that we zeroed in on when we were looking kind of the filtering of an application map. But from this, you can sort of see that if you need deeper details or a particular view, or maybe there's a particular Grafana workbook package that you really like, you have the capability to be able to leverage Azure Monitor's data collection and kind of data repository and visualize it through a tool like this. And it's just as full featured as the regular one. You just, as Grafana that you would get from Grafana Labs, it's actually a co-built product. And so it is fully managed by Microsoft. You don't have to worry about the infrastructure. And it comes with several of these types of dashboards, especially are useful around AKS. Because in this particular one, you can kind of see what my filters are. In this case, I'm looking at my cluster inside that resource group. There's only 2 namespaces available, so kube system and default. This workload is deployed default, but you can come down and see what my memory sets are by pod, and sort of what the CPU usage on those pods are. And so as you start maybe in application insights and you start to get a feel like maybe you're having problems in Kubernetes and you want to understand sort of what's going on in that space, tooling is available to be able to get pretty much as deep as you want in that collected nature. With that, I recognize that we're basically out of time. So Derek, Tom, were there any questions in the presentation or in the chat?
Nothing in the chat. So I did pop in links to our next sessions. So if anybody has any last minute questions for Jeremiah, let us know and we can get those answered. In other words, those links are in the like I said, in the QA session, QA chat. So go out and get registered for our next sessions or pass those along to colleagues that you think might be interested in attending. Oh, if no questions, if you think of anything after the fact, go ahead, please reach out to your Microsoft person and we will make sure those get answered.
Absolutely. And thanks for your time and attention this afternoon. We appreciate you taking the time to join us for this.